everyone. Welcome to our next session. In a previous session, we saw what was unsupervised learning, right? We have seen two different categories under supervised learning. One was clustering, and the other was association, right? We've seen an example of how unsupervised learning can be distinguished. Uh, this is an example which we saw in our last lecture, that a friend invites you to his party where you do not know any of those persons. You're meeting everyone as a stranger. Now you need to classify them using unsupervised learning. That is, you're unaware of any of those persons who are being invited in the party, and you, as in being a friend to them, will classify them on the basis of gender, age group, their dressing style, and education qualities, right, and so on. So this, the prior knowledge was nothing, yeah, right. So this kind of category where you classify on some constraints is called as unsupervised learning, right, because you did not had any past or prior knowledge about the people which you are going to classify them, right? So one more example we saw, that NASA discovers some heavenly bodies and finds them differently from previously uh, known objects, right, such as stars, planets, asteroids, etc. Right. So when they find a new heavenly body, the prior knowledge is zero. Right. So they need to make some categories. They need to make some analysis over those uh, new discovered body. Right. So you need to classify them. Supervised learning has input and correct output, whereas unsupervised learning has inputs. Suppose for this example, you are having this kind of data wherein red circles here would indicate the visited restaurants, right? A person who has visited these restaurants, whereas in blue circles, these indicates that the restaurants which are not visited. Hmm? Now the problem statement, right? We always will be having a problem statement wherein we'll be finding out an optimal solution, right? We will be finding it more accurate answer while to predict. Hmm? So if I have two restaurants to choose from A to B, right, I want to choose a restaurant amongst A and B marked by green colors in this image, right? So my question is, which one will I choose? Either I will choose restaurant A or I will choose restaurant B, right? So the classified part is between green circles as A and B for choosing. Based on what categories? There are two categories made here. In red circles, the red circles indicate you the visited restaurants. That means I'm frequently visiting to this restaurant, and blue circle indicates that those restaurants which are not being visited yet, right? So what will I choose? Basically, I'll go for B point, the green B point over here. The reason is that I'm near to these restaurants, right? And these blue circles, they are far away from me, right? So I will not go in such an area where I want to choose a restaurant which I have not visited, I am not aware of, right? So most probably I'll reach out for those restaurants which are nearby to me, and probably I have visited them many times, right? So this will be the basic difference. So this we call it as supervised learning, because I'm having a prior data, right? What data I'm having is these are not visited and these are set of visited, right? Now if we classify this given data into linearly two parts, now we are going to do, we are going to divide it into linear parts, right? So this was our previous data for visiting of two restaurants which have been previously visited and not visited. So what we have done here, we have drawn a straight line and divided these two data, classified them into two different parts, right? Now after dividing, there's the same position, but there will be two different categories now: visited and non-visited, right? So we draw a line in between these two categories and divide it into two different parts. Now we can say that the chances of visiting B is more than A, right? Because I need to choose now one category, right? So no person going for a restaurant will choose A where he has visited the least, right? Because that area, the other part in the blue circles, is unknown to him, whereas the B part is frequently visited, right? So this is the case of supervised learning. Now for unsupervised learning, you won't have any prior data, right? As in here you had two different categories. This was data related to visited and not visited, right? So there were some labels, there was some input provided you, there was some prior knowledge given you regarding these red dots and blue dots, right? But in unsupervised learning we do not have any data. Now let's see the same problem statement with a different perspective so as to understand what is unsupervised learning, right? So let's suppose we have a taxi driver who has an option of accepting or rejecting the bookings, right? You use many times in metropolitan cities, we use Ola, Uber, right? We go onto that application and click on a taxi driver nearby us, we ping it, and if the taxi driver is available he responds back and comes to our location, right? So being from looking at the taxi driver's perspective, he'll be having the same application but with a different choice. Now if suppose two persons at the same time are trying to ping that person, right? One person is from location A, one person is from location B, right? Now here the diagram this depicts that the plotting of his accepted booking locations on the map, right? So what we are seeing in this table over here is the map diagram of a taxi driver who has accepted the bookings, right? Suppose this user over here was uh, has been pinged him his location for calling up a taxi, and he was here nearby, so he picked up this booking, right? Similarly he went on for these blue circles indicates that he has visited these frequently. Now you can see that the person right now here is calling, there are two persons from these green points, that is A and B, for the same taxi driver. Now our problem statement is that which one will the taxi driver select, right? He may select A passenger, or he may select B passenger, right? But these will be from two different areas. Now for an unsupervised learning, right, we are only having the data that he has visited these areas which are showed in blue circles. Now what is the probability that which one will get selected and which one will get rejected? Hmm? So which one to choose? Obviously he will go for the B one because he has most frequently visited on that area on the left bottom corner. So the taxi driver will not choose this A circle over here in this green part. He will obviously going for this B part, right? So this is the most frequently chosen by the taxi driver. Might be he is well aware of that area, might be he's frequently visiting that same customer, right? So we'll be choosing the B circled area. So what we do is we form a cluster, right? Cluster is something a grouping of similar items, right? So here similar items are those bookings which are being frequently visited into the same area, right? So these all points are nearby, they are similar, they relate to one area. Remaining rest of the points you can see are distributed, right, over the map, right? They are not so near to each other, right? So what the taxi driver will think that B is the most frequently visited, I'm aware of that area, might be the passenger is also the same who is daily visiting, right? So he'll choose B. Right? Now, the last part of machine learning, we have seen three different categories: supervised, unsupervised, and reinforcement. Right? So we're going to see what is reinforcement learning. Right? It is about taking the suitable actions to maximize your reward in a particular situation. Right? So what we are going to see is the action. What action? Uh, Wherein a particular agent will be trying to find out possible ways to reach his goal, right? It is employed by various softwares and machines to find the best possible behavior. The reinforcement agent, right, the agent, what we call him as the reinforcement agent, he decides what to do to perform the given task, right? Remember the definition of machine learning: a particular task is given as T. So based on his experience E, he tries to improve his task so as to reach the goal, right? So in the absence of data set, here no data set or prior knowledge will be provided. So it is bound to learn from its experience. Now what he is going to do, the reinforcement agent, he is going to learn, he is going to make some uh, iterations, much more possibilities, from where he can find out a suitable option, the optimal option, that it would take less time, more efficiency, more accuracy to reach his goal, right? So he on his own will be deciding what would be the suitable path to reach his goal. So for example, let's consider an agent and a reward with many hurdles in between, right? This is just as a game wherein you are open to go anywhere, right? But your mission or your goal is fixed, right? The person who is going to play the game will decide where to go and how to go, right? So the game developer has to think of many possibilities from where a user can reach to his goal, to his mission, right? So in such way, we'll see an example here. You can see this. Here is our reinforcement agent, right? And these fire are your hurdles, and this diamond is your goal, right? Now I do not know that how to reach to this point. The optimal way would be this, right? From top to my right, again to my right, then bottom, and then to my right, right? So if I get these instructions, I'll be getting the optimal path. But this is the easiest one, right? But the data, actual data, would be very complicated and complex, right? So what if I try directly going into this, right? This is my first hurdle. What if I step into this box, right? I won't reach to my goal. So like this, I'll go upwards, then I will again go right, then I'll again try to go down, then again an hurdle. In this way, I will be trying all the possibilities, right? Moving from this position to this position. And what I'll do is I'll try to find out the optimal path, right, to reach this goal. So this is the responsibility of this agent, to discover multiple possibilities to reach to that reward, right? To this diamond part. And obviously he will be collecting the data of different paths. See here, you can go from this path, which is the optimal. You can choose this path, come back again and go to this path, because he need to survey all the possibilities, right? He will be going in this way, trying to search here, he will fail. So he will record this experience and try to learn at the next time that this path will not lead me to my goal. So this will be recorded as an experience and will not be selected further, right? So this agent, this robot, learns by trying all the possible paths and then choosing the path which gives him the reward with the least hurdles, right? Stepping onto least boxes, that is your more accurate, more efficient way, and reaching up to the goal. Okay, so these were three points, categorized points. We'll be seeing in our next modules how to implement these in machine learning algorithms using R programming. Now coming up with a small point in how data is in machine learning, right? So data can be unprocessed fact, right? That mean be in a raw format, right? Raw text, value in some terms of value, text, sound or picture, right? That is not being interpreted or analyzed, right? So everything will be in a raw format. Data is the most important part of all data analytics, machine learning, and artificial intelligence. Hmm. Without data, we can't train any model, and all modern research, all automation will go in vain. So we need some structured data always, right? So data must be in a well organized manner, in a structured way, wherein it can be used for further analysis, right? If you are having only data and we cannot make out any analysis or prediction, then the entire data is of no use, right? So no automation can be performed on such data. Some information related to a real time example, that did you ever notice why Facebook acquired WhatsApp by paying a huge price of $19 billion, right? You might think that what's why Facebook, such a big company, such a big social media platform, is trying to buy WhatsApp, right? It will have the access to users information, right? That Facebook may not have. Many people won't be having a Facebook account, but will be using WhatsApp to share your documents, right? So now he's having the phone numbers of the users, which would help them as Facebook to improve their services, right? This is one of the democratic answer, that they would help getting that data and trying to improve their services, right? So this data is being shared by Facebook via WhatsApp. Talking about information and knowledge, I told you the difference between information and data previously. Now this is a diagram which will show you the actual path of how data is being used in different phases, right? So data is something which is in unstructured format or in a raw structured way, right? So information is data that has been interpreted and manipulated, right? So I'm trying to extract something from the data which has been interpreted and manipulated and now has some meaningful interface, right? So it is holding something out of that entire data, a very small part, but which is very useful, right? Now it is being converted into knowledge. So what is knowledge? It is a combination of inferred information, experiences, learning and insights, right? It results in awareness or concept building for an organization, right? So where does it come from? It comes from an information, right? And what is information? It is an extraction or some manipulation of what actual unstructured data I was having, right? So I need to reconstruct my data so as to get information, and when I try to implement it to build up a model, I convert that information into a knowledge. Okay. Now splitting up the data, when you are going to use machine learning, you are going to try to build up a model, you may find these three cases that your data might be divided in. First will be training, second will be testing, and most probably we go on validating that data, that how accurate it is, right? Because some there might be some classifications, some clustering, or some integer values when we go for regression, right? So we have a particular fixed value wherein we compare it with your actual value and the predicted value, right? So we'll be going for validation of training and testing data, right? So these are some categorization of data in machine learning. Okay, I hope that you are getting these points. I'll In next session we'll be seeing for module 2 some basic programming fundamentals related to R programming.